Welcome back to our unit on the killers. We are going to cover what protects us from disease. So let's get started. We're going to talk about diseases from the outside. We were previously talking about more about diseases that come from the inside, or diseases that really were kind of human caused, like heart disease, diabetes, or genetically caused. And these we're going to talk about diseases coming from the outside, or invasion, and microorganisms. So, invasion and multiplication of microorganisms such as parasites. So, parasites you can think of like tapeworms in your intestines, protozoa, or think of malaria, which is very prominent all around the world. Fungi, which you can find in athlete's foot. Prokaryotes, or bacteria. There's lots of bacteria. You can think of like E. coli infections from eating bad food. Leprosy is also a bacteria. Viruses, lots of viruses we've heard about, HIV infections, the flu. Lately, we've heard a lot about coronavirus. Prions, you may be thinking, what's a prion? CJD is a neurodegenerative prion. One you may have heard more about is a prion that causes mad cow disease. So these are all lots of microorganisms that can lead to tissue injury and illness through a variety of cellular and toxic mechanisms. So we're going to talk about these and how our body defends against them. So first we're going to talk about, we're going to define some terms and talk about from the public health side. So what is a pathogen? So we just talked about microorganisms. Are they pathogens? They are. They cause disease, and in order for them to survive, they need to be transmitted. So they're a little bit different than like heart disease. Pathogens need to be transmitted to survive. An antigen is something we'll be talking a lot about. It is a toxin or a foreign substance that causes an immune response. So pathogens can be an antigen, but also lots of other things can be antigens, like pollen, and can cause an immune response. Virulent is how strong is something strong enough to overcome host resistance. So if a pathogen is strong enough to overcome host resistance, then it is virulent. An epidemic versus a pandemic. Some people get these terms mixed up. An epidemic is a disease outbreak that affects many people in a community. And an example of this is a college outbreak of a sexually transmitted disease. And let's listen to one of these.
SDSU officials say they identified their first case of syphilis late last week. Then the county notified the school of some additional cases on campus. Dr. Greg Lichtenstein is a medical director of SDSU's Student Health Services. He won't say how many students became infected, but he will say it's a small number.
What's unusual in this situation is that we don't see syphilis that often. I've been here since 1984, and there's probably only been a couple cases over that period of time.
Syphilis is spread through unprotected sex. Health officials say people can be infected with the disease and not know it. SDSU students can get tested for free on campus or at county health centers. Kenny Goldberg, KPBS News. SDSU officials say
So a community having an outbreak of a disease is an epidemic. So that can be at a college, it can be in a city, it can be any type of small community. So the thing where we just heard at San Diego State having an outbreak of syphilis, while small, it can lead to an epidemic of syphilis in their college. A pandemic is a global outbreak where it breaks through barriers of community. So it passes through borders and it goes through different communities. An example of this is pretty easy. So the SARS-CoV-2 pandemic, or the COVID-19 pandemic, lots of names for the pandemic that many have experienced lately. There have been a few pandemics before this, but this is the most recent, and people are feeling this right now. So what is immunity? How do we stop from these outside pathogens? The word immunity is derived from the Latin immunis, meaning exemption. Immunity is a condition of being able to resist a particular disease by counteracting the substance that produces the disease. So it really means being exempt from the disease, and it's meaning it being able to resist it. So immunity doesn't mean fighting it. It really actually means fully resisting it. It is a weird kind of word, immunity. Your immune system does a lot of different things to be able to resist diseases. So let's look at it a little bit closer. Where does immunity come from? It actually comes from so many places in the body. Unlike the central nervous system, or the the pulmonary system, unlike all of these systems that are very tightly contained, the immune system, or immunity, is all over the place. We need it everywhere. We need to fight these pathogens that are coming at us everywhere. So this is a very long list, and it actually doesn't include everything. But let's go over it a little bit. And so these are some of the main parts of the immune system listed here. The bone marrow is where most of the immune cells are produced. The thymus, which is located here, just under the breastplate, above the lungs and heart. It is the site of specific immune cells called thymus cell lymphocytes, or T cells. That's where they mature there. The lymph nodes are located all around the body. You might be able to feel some under your neck, behind your ears. They're located all around the body and they act as blood filters. Your spleen stores various immune cells as well as scavenger cells, and it also acts as a really giant filter. Your tonsils, if you still have them, some people have them removed, can stop germs by entering through the mouth and nose. Contain a lot of white blood cells, which are responsible for killing germs and entering in through our mouth and nose. And our mucous membranes, which line both our respiratory system and a lot of our gut system, and our bowel, really plays a central role in defending our body against pathogens. More than half of our body's immune cells that produce antibodies are found in the bowel. Most people don't think of our immunity being found in our gut, but it really is. Think about how many things we breathe and eat, and how things get into our body. And a lot of things get into our body by us eating them, and our body needs to defend against it. And a lot of the antibodies are in our gut. Other things can be found. Our skin, it is a physical barrier. It actually has some antibacterial properties. It is a little bit acidic, and some of the sweat and oil glands produce some antibacterial properties. We talked a little bit about the thymus, which is pointed here. The lymph nodes, which are pointing here in the legs. Our lymph nodes are all around. The urinary tract system talks a little bit about washing away microbes after they're being filtered. The large intestine, again, is really central to our immune system, as well as the stomach. Helps the stomach acid helps kill pathogens. The stomach acid is really central to killing a lot of things that we eat before they go out to our bowels. The respiratory tract, the nasal hairs and things help trap microbes and the mucus in there. And the cilia helps sweep away the debris, and all of the cells in there help trap all of the microbes and filter them out. The tears in our eyes help wash away the irritants and microbes, and the lysozymes kill bacteria. So there's a lot in our body that help us defend against all of these pathogens that can come at us from many different areas. So much in our body that helps keep us immune to things. There are different types of immunity. So there are so many different labels to immunity. It can be very confusing. There's people, many immunologists have labeled them so many different ways. So I tried to break it down a little bit easier. Your textbook mentions it in many different ways that is kind of confusing. So let's go through it a little bit. Acquired immunity means immunity that is developed over your lifetime. And it can be broken down into two different ways: active immunity and passive immunity. Active immunity really means you develop a response to an infection or vaccination. So your body is developing its own immune response. Passive immunity actually develops after you receive antibodies from someone or somewhere else. So let's talk about active immunity. There's natural and artificial. Natural means antibodies are developed in response to an infection. So, active immunity, my body is developing antibodies. You can do it in response to an infection. So maybe I got the chicken pox, and I got it from my little brother, and now I have antibodies to the chicken pox. Or you can have artificial active immunity where, I was old enough that there was a chickenpox vaccine, and I was lucky enough to get that vaccine, and I got antibodies to the chickenpox. Either way, next time my body sees the chickenpox virus, it can defend against it because it has antibodies. There is passive immunity, which is really interesting. You can have natural passive immunity, antibodies received from a mother through breast milk. So this can happen during breastfeeding, and this goes through the baby's gut. And then there's artificial antibodies received from a medicine, gamma globulin injection, or infusion. There's a lot of medicines that are, you can get antibody treatments. Either right now, they are putting medicines on trial through COVID. So people that have had COVID-19 and have cleared it successfully can give antibodies to people who are currently ill in the hospital to help try to treat them. So that is one artificial way to give antibodies and receive them. So those are some types of immunity. There are other types of immunity as well. There are so many types of immunity, so many categories. There's innate immunity and adaptive immunity. Innate immunity really means non-specific. Innate immunity is kind of your body's immediate response to something happening, whether you get like a cut or the flu. Your body like immediately responds, and this can take up humoral or cellular response. And there's a couple different actions in there, and we won't go too deep into there, but there's some different types of cells and signals in there. Or adaptive immunity, which really is like the big daddy. That's kind of where your body remembers. That's where you get the antibodies. That's where your body's like, ooh, I know what this is. I know what this chickenpox is. I remember what this is. I know exactly what to do with this. We can bring in the chickenpox army and fight this. So the innate immunity kind of can cause some fever, a little bit of, inflammation. It can kind of cause a little bit of non-specific things. The adaptive immunity is really the big daddy, knows what is going on. And there's some different types of cells going on. Both types have humoral and cellular responses in it. So, um, looking deeper into innate and adaptive immunity, what types of cells are going on? So your book goes into some types of cells. They're all blood cells. These are all found in the blood. And they're all kind of circling around, but they're all different types of blood cells. And they all have cool things going on in them. The innate immune cells can are kind of seekers and eaters. They go out and they kind of like eat things up, and all of these little granulars in here are in there so that they can destroy the bad things that are out there. Same with these guys in the middle. These T cells over here in the adaptive immunity really interact with antibodies. They really need the antibodies this is where the memory comes from. The B cells and the T cells really need those antibodies to interact. So these are very specific. And the middle ground, this is where you get like if there is an infected cell with that is infected with chickenpox, like a macrophage might eat a cell with chickenpox, then it will recruit some of these guys and say, hey, you should remember that this cell has chickenpox. So it's kind of a talk back and forth. And then this B cell will call its more buddies. So we'll talk about that a little bit. So there's some middle ground where these guys can talk with some of these cells over here. But these mast cells, neutrophils, and monocytes are really, all these little granulars are over here just kind of killing bacteria and bad cells off. Same with these middle guys. They're just over killing bad guys. All of these guys are creating memory so that they can help remember and kill quicker. So how does the immune system work? Well, the innate immunity, remember, is very general and can respond to bacteria, fungi. I always say to like ouchies. Like if you get an ouchie or like a little infection, this is where your innate immune system kind of acts. It could be other things. It doesn't have to be this. It definitely acts at other things for sure. But this is what's going on. So if you get a cut, and you get a little bit of bacteria in your cut, what happens is you get an inflammatory response. So the cut, the mast cells, remember those cells with those little granulars, secrete histamines, and the blood vessels dilate. So those histamines, it creates this like chemical response. So the blood vessels dilate, and then the cells can then migrate to the cut where the bacteria is. So if you're getting cells migrating to the cut, then you get a little bit of redness and swelling where all these white blood cells are going to the cut. That's also what creates sometimes pus and other yummy things at your cut. Cytokines, also other chemicals, send feedback to the nervous system overall that brings symptoms of like feeling sick. You can start to get a fever. you can start to get pain, or muscle pain or nausea, depending on how bad your cut is. So that's what the innate immune system does. So it's an inflammatory response. It cuts. There's some cell signals. It's very general. It doesn't really matter what's happening. It's chemistry. It's like, oh, hey, something's happening over here. There's a bad thing happening over here. You should react. And it recruits the cells, and then the cells eat what's going on over there. The adaptive immunity is very intentional. This is the big daddy. These are the memory B cells and the memory T cells. This figure is in your textbook, and is maybe a little bit harder to understand, but we'll go over it a little bit. So what happens is antigens, so remember, like either a pathogen or sometimes even something like pollen, can invade the body. So maybe thinking you either breathe it in, like the flu or pollen. It invades the body and breaks the barriers. And then the helper T cells, in conjunction with that innate immune system, you actually need other cells to come in. The helper T cells recognize it, and they're like, oh my gosh, something I recognize. I've seen this before. I remember it. They recognize it and trigger the production of killer T cells and B cells. So they say, I recognize this chicken pox. So they trigger the production of the killer T cells and some B cells, which create the antibodies, which then go out and start fighting the infected cells. So they go on the hunt throughout the body. Instead of going to a local site, they go on the hunt throughout the body. They're like, I'm on a search and destroy mission. I know exactly what I'm looking for. I'm on a search and destroy mission, these killer T cells. And the B cells are producing more antibodies because they're like, ooh, we need more antibodies so we can tag all of these bad guys. And then when the threat is over, when they feel like there's no more bad cells out there, there's suppressor T cells that stop the process. So then you're not making more cells. It's actually a really cool system. This is the Big Daddy Army search and destroy. It's very specific, whereas the innate immune system is chemical, and they just kind of are like, hey, come on guys, something's happening over here, we just need some help. Whereas this one is very surgical search and destroy. There are a couple disorders of the immune system, which is very interesting. You can be immunodeficiency or the bubble boy. There are cases of people not having a functional immune system. There is this boy in a bubble where it's very dangerous to live in society and see anything, basically. You can also have an autoimmune disease like multiple sclerosis. This is very tissue specific, where your body attacks your immune system attacks something like a tissue. Multiple sclerosis, lupus. There are many autoimmune diseases where your immune system is overreacting. Inflammatory diseases like meningitis, rheumatoid arthritis, where that inflammation is overreacting. There's too much inflammation. Lots of disorders of the immune system. Cancer can be a disorder of the immune system. Some of the wonderful things about the immune system is it actually searches and destroys bad cells, not only from the outside, but from the inside. It eats up cells that are dividing too fast. And if the immune system is not working properly, it can miss some cancer and not eat up cancer. So one of the things people are researching is the immune system in conjunction with cancer. Okay, come back and we will learn about the immune system and health.